Now I want to talk about what I call the 7 steps of the teaching progression. I'm going to refer to this, and many times I will teach in this manner. There are 7 steps of the teaching progression. The first is terminology. And these are kind of steps, but not entirely steps. Sometimes you may switch the order a little bit. Terminology, facts. Okay, so we have terminology, facts, concept. Then we have procedure. Each of these is a step, and I want to give a definition and explain exactly what I mean. Expansion. And problem areas. And last is everybody's favorite, application. Okay, so there's the 7 steps of the teaching progression. We have terminology, facts, concept, procedure, expansion, problem areas, and application. So I'm going to go through each one of these and tell you what I mean by them. The first is terminology. This is defining words that you will use in your class, or in this particular class, or at this particular level. It's vocabulary. Defining the words that you will use in this class or at this particular level. You will find that your students do not have the same math vocabulary as you do. This is related to the law of what? The law of language, right? The 7 laws of teaching. So the students have to learn the language of mathematics, and you want to deliberately work to build their math vocabulary. So terminology is when you define the words that you will use in your particular class and at your particular level. 2 things about that: the students must learn the language of mathematics, and you will work to build their math vocabulary. We have a running joke in 7th grade math, and it relates to this. The running joke is, do you speak English? And that's because their math vocabulary, especially at the beginning of the semester, is not the same as my math vocabulary. And I have to pay attention that the students know what I mean when I use certain terminology. And some of it's very obvious. We spent one class period in 7th grade math a couple years ago. We spent, 10 minutes, maybe 15 minutes reviewing how to measure angles with a protractor. And then we spent time going through the names of our angles. Remember, acute. What's an acute angle? Less than 90. Acute, then there's the right angle. Obtuse, more than 90, less than 180, then the straight angle, etc. We learned the names of all the different angles, and we reviewed how to measure angles with their protractor. I assigned the homework, picked up the homework the next grade, graded it the next day, graded it that night, and I would think there was 12, 13, 14 7th graders in that class, and 3 or 4 of them didn't measure a single angle. The directions said, measure the angles below and name them according to their degree. What do you think those 4 students did and only did? What do you think?
Just looked at the angle and then what it looked like, then wrote it down.
Then they wrote, yes, acute, obtuse. And one of the boys even said to me in class when he got his paper back, he said, "You mean we had to measure?" And before he even got the word out of his mouth, he realized that he completely ignored the directions. Because students don't read directions, and sometimes they misunderstand terminology, even something as obvious as that. So the students must learn the language of mathematics, and you have to work to build their math vocabulary. Work to build their math vocabulary. What do you think I mean by the idea of working at it? What do you have to do when you're working at something? You have to deliberately plan to accomplish it, right? So when I say work to build their math vocabulary, you have to deliberately plan to accomplish something. How are you going to deliberately plan to accomplish this goal of building their math vocabulary? What are you going to do? I'll give you an example. The first thing you're going to do is use the terminology yourself. If I'm teaching about multiplication, do I put my multiplication problem up on the board, point at the number, and say, which number does whatever? No, I will call the number by its name. It's a factor. So I deliberately use the terminology myself. And the second thing that I will do is I will require the students to use the terminology. We've got to deliberately make ourselves and our students use the proper terminology. Then it becomes part of their vocabulary. So we're working to build their math vocabulary. As a teacher, you should be working to build all their vocabulary in general. Use bigger, harder words a lot, as much as you can. Explain what you mean, and they'll get used to your vocabulary. You want to raise your students' vocabulary, not lower your vocabulary, right? So to do this, you've got to be deliberate. I still have to be very deliberate that I'm using the terminology. So if I'm teaching multiplication again, do I ask the students, what's the answer? How do I phrase that question? Somebody? Yes. What's the product? Or if I tell them, let's say another problem with a large multiplication problems is those partial products, being sloppy and misaligned, right? You understand what I'm saying? Just sloppiness. And so if I'm talking about the partial products, do I point at the numbers and say, keep these numbers in a row? No, what do I say? Make sure your partial products are aligned. So when I'm talking about terminology, I use it. If I'm teaching division and I'm talking about the answer, and I'm talking about how important it is to put the number in the right place above the dividend, I keep calling it quotient placement. Make sure you put your quotient in the right place. So I am deliberately working at building their vocabulary. And I do that how? By making myself use it, deliberately planning and trying to make myself use the correct terminology, thinking as I'm speaking, and then when I call on students and they answer questions or they ask questions, I try to get them to stop asking questions like, what's the answer, or what's the number, or why is that number? So instead of using that number, or if I'm teaching about subtraction, instead of using the top number, what should I call it? The minuend, right? So I have to work at building math vocabulary. All right, so terminology is when you define the words that you will use in your particular class at your particular level. And I don't mean that necessarily for elementary students that you give them this big fancy definition, okay? Even if I might give you some big fancy definitions in this class, but you let them know what they are and then you start using them. So work to build their math vocabulary. So first of all, with terminology, terminology is when you define the words that you will use in your particular class and on a certain level. Second thing with terminology is then you will show the terms how they're going to be used. Show how the terms are going to be used. I read that wrong. So we're talking about terminology, we're talking about vocabulary. The point here is that learning vocabulary is more than just memorizing a definition to put down on a quiz. So it's not just memorizing a definition to put down on a quiz. It's incorporating the terminology into what we are doing. So the idea is not to memorize a definition for a quiz. The idea is that for them to understand the term and how it is used. And then, of course, begin to use it. All right, the last thing that we're dealing with terminology, I guess it's kind of a pet peeve, but I think it's important. And that is require proper spelling of terminology. we all have a human nature that tends to be lazy. And so if I'm not required to spell something correctly, I get in the habit of laziness with my spelling. But if I'm going to get docked when I misspell, I'm going to start paying more attention to it. So require them to spell things correctly. And that will help them with their overall level of education. All right? Nothing shows poor education than misspelling of commonly used words. So help your students with their vocabulary and with their own personal education and knowledge so that they have the habit of paying attention to spelling. Students don't do that naturally, do they? So we help them along wherever we can, and we make them spell things correctly. And kind of along those same lines, make your students give you neat work. If you let them turn in junk, they will turn in sloppy, messy junk. And their math especially, they're going to have a lot of mistakes because they can't even read their own numbers, or the numbers aren't lined up, so they add the digits incorrectly, or different things. Math is very much affected by sloppiness. So if you let them turn in a mess, they're going to turn in a mess. And it's a pain to have to make a student redo assignment and make sure that you get it back and so forth. Those things take time, but they're worth it. And you do that at the beginning of the year. I think there's a little expression that says, inspect what you expect. Okay, so if you expect neat papers, but then you don't do anything about it when you get messy papers, you're just going to get messy papers. And are they going to get better as the year progresses? No. And that's going to just help the underlying character of your students too. A lot of education problems are character problems. I always kind of say I rarely have ever met a student that really has a learning problem. And I kind of like to say there really aren't any dumb students in my class. What kind of students do I have in my classes? Lazy ones. A lot of them are mentally lazy. They don't have the habit of focusing their mind, getting down to business and working. That's the biggest problem that throughout the years I've always had, is lazy students, or students that cannot focus their mind and get down to business and accomplish a task. That really shows up in which class? Math class. Okay? All right, so terminology. Number 2, the second step in our progression, we're going to make sure we know the terminology, know how it's going to be used, and then we use it and make sure they spell it right. Okay? Facts. These math facts include the information necessary to do math operations. This is the information necessary to do math operations. Let me give you a list of 6 examples of what I mean. Math facts. First one would be the addition and subtraction families. Addition and subtraction families. Okay. Flashcards, of course, are involved here. The next is multiplication tables. A third example, measurement conversion facts. Okay, just imagine walking down the hallway in the academy and you hear this. 1 foot equals 12 inches, 12 inches equals 1 foot. The chant, I don't like the chant, by the way, but that's what I mean by measurement conversion facts or factors. Terms and definitions can also be a part of the facts that you are going to be drilling. Formulas. Geometry terms. Those are some main examples of things that I would drill, things that are necessary to be in their mind already. If I'm going to concentrate on long division, I have to really know my multiplication tables. Okay? Or if I'm doing a big multiplication problem, I have to know my multiplication tables so that I can't do the operation if I don't even know what 7 times 8 is. Or I get it mixed up and I put 54 instead of, what's 7 times 8? 56. A lot of students put 54. That's 6 times 9. It's close. But you've heard the saying that close only counts in horseshoes and hand grenades, right? It doesn't work very well in math. So they have to know their multiplication tables. So we've got the addition and subtraction families. How hard is it to teach borrowing in subtraction if we don't know our subtraction facts? If we don't know automatically 13 minus 8 is 5. So what we want to do with our math facts is we want to have them automatic. So the key word here is automatic. With terminology, I kind of have something I want to put behind each one. We'll put this little phrase here. So when you think about the first step, terminology, the thing I want you to think about is use it. Here with our math facts, what I want you to think is this. It's not a phrase, just a word. Your math facts have to be what? Automatic. So when I'm concentrating in grade 2 on teaching math or subtraction borrowing, I don't want the students to be tripping, quite literally, tripping over the subtraction facts. All right? What's going to cause them to miss the problem? Not knowing how to borrow or not knowing subtraction facts? Both. The problem's just as wrong if I borrow wrong as it is if I write that 13 minus 8 is 6 or 7 or whatever, okay? The problem's just as wrong, whether they miss the operation or the procedure or they mess up on the fact. Okay, so these facts have to be automatic. Addition and subtraction families, multiplication tables, measurement, conversion facts, terms and definitions, formulas, geometry terms, and even geometry formulas. Does anybody notice what I left off the list? Yes, division. This is my quirk. I don't drill division facts because division is the inverse of multiplication. And I suppose I don't teach at lower level. You probably only drill that at lower level. Very good. I want to see who would notice what I did not put on there. I did not put on there division tables. There really aren't any. You drill the division with the multiplication. But you can add that because they do need to know their division facts. So addition and subtraction, multiplication tables, parentheses with division, measurement facts, measurement conversion facts, terms and definitions, formulas, geometry facts and formulas. So that's what math facts are. It's the information necessary to even do the math operation. The second thing is that facts must be drilled, reviewed, and taught daily. Drilled, reviewed, or taught daily, even for just a few minutes. Now there's a balance here. You can't spend 15 minutes on drill. And you even have to be careful spending 10 minutes on drill. But every day about 5 to 10 minutes on drill. Now if we're having a problem with our subtraction facts, when we subtract 13 minus 8 or 14 minus 8, sometimes they have trouble with those teen subtraction facts, which becomes a disaster when we're borrowing. Why? Because we're borrowing 10, aren't we? And so we have to know our teen subtraction facts like the back of our hand automatically, or we're going to be making all kinds of math errors and we're going to be missing our problems, even if we know how to borrow. So if I'm having a problem, I might extend drill. Or if it's a review lesson and I'm not teaching a concept that day, I'm reviewing concepts, I might stretch my drill to 15. But you've got to keep tabs of your classroom time. So the second thing with facts is that it must be done daily, even for just a few minutes. 2 ideas again is you want to do around 5 to 10 minutes a day. I'm talking about a 45 minute class period. But extra time can be spent to address problem areas or on review days. Drill is essential, and children that are homeschooled often are weak on their facts because they don't get as much drill, or sometimes they might not get any. So many of you will need to homeschool your own children, or many of you might work in a situation similar to our learning center, where you have PACEs and it's kind of a one-room schoolroom concept, one-room classroom. You've got to spend time drilling. Maybe you go to a small school, or maybe you're on the mission field and you have a small school, or you have your own kids and a few other kids. What you want to do, oh, by the way, kids are baby goats, students. Okay, and you only have a few students. You want to drill, and you want to drill to the upper child. Why? You'll pull the younger children up to their level, and you always want to be challenging. We're going to talk a whole day on drill, but there's a little preview. Drill must be done daily, even if just for a few minutes. The third idea is what I just said. Drill is essential, even in the small classroom or in the home. If you have to, you may be homeschooling your own children, buy flashcards, and even if it's one-on-one, it's very important to get those math facts automatic. You don't want your students, or your own children for that matter, to have trouble in math because they're always having to take a minute and think about what is 8 times 7. That's going to make their multiplication and their long division very slow, cumbersome, and frustrating. Okay, all of those sound bad. Slow, cumbersome, frustrating. It's frustrating not to know your math facts. All right, so fourth thing, facts are essential to learning math procedure. I've already said this, but we'll put it in the outline. Math facts are essential to learning math procedure. You can't do long division if you're weak on your multiplication tables. Or it will be slow, cumbersome, and frustrating. Or if you're always missing your problems because you multiplied wrong, because you don't know your math facts, or you made a subtraction error, it doesn't make any difference if you know how to borrow if you don't know the math facts. So they are essential to learning math procedures, like borrowing, like long division. All right, so you cannot learn a principle or procedure without knowing the facts in the steps. You can't learn them, okay? How can you borrow if you don't know your teen subtraction families? Because in borrowing, you will be borrowing 10. So when you have a 4 up in the, what's that top number called? Anybody here besides me? No, the top number of subtraction. Minuend, okay? In the minuend, when you borrow, you're going to be borrowing a 10. So if you have a 4 in the minuend, right, and an 8 in the, what's the bottom number? Subtrahend, you're going to have to know a teen subtraction fact, 14 minus 8. So those teen subtraction facts are often confused, and they have to be, what's the word? What's the word? Automatic. Okay, so when we're teaching math facts, it's important. Drill is important, but there is a balance to it, which we will deal with. So you can't learn a math process or procedure without knowing the basic math facts involved. Okay, as illustration, you can't do a multiple digit factor multiplication problem like 385 times 28 if you don't know your multiplication tables and you don't know them well. It'll take you too much time and you'll get frustrated with it. You can't do long division if you don't know your multiplication tables very well. You can't borrow if you don't know the teen subtraction families. All right, the last thing here with essential to learning math procedures is that you don't want students missing problems over and over again because their facts are wrong. That's frustrating, okay? I don't know about you personally, but maybe you've had experience yourself being frustrated in math class because you're behind. In one way that you might be behind in is that you don't have those facts right on your fingertips. okay? The last thing with facts is that they must be drilled. It's my capital letter E, if you're with me. They must be drilled to the point of being automatic. They must be drilled to the point of being automatic. What do I mean by automatic? I mean, first of all, no thought required. They don't have to stop and think for a minute. No thought required. And then number two, they see the flashcard and immediately know the answer. Or they see those numbers in a multiplication problem or in a subtraction problem, and they immediately know the answer. It's right there on their fingertips. It's right there. How is that accomplished? Drill. Okay? Now you guys have been out of school for a while, and your math facts may be floating away from you, and they're not quite at your fingertips, but if you're a teacher, you better get there really fast, or you're going to be embarrassed when you drill your students, right? I've been there, done that. Didn't know my math facts quite as fast as the class. If you do your student teaching and you're assigned to math, maybe 3rd and 4th grade level, or 5th or 6th grade level, you will have to brush up your own facts. Or you might have to cheat, have the answers all written out. Or if you're drilling a times table and if you're a little slow yourself, read them, okay? We'll talk about how to drill later. All right, so terminology, facts, concept. Let's get through number 3 here so we can pick this up next Friday. Concept. Concepts are principles, laws, theorems, etc., that govern how math procedures are done. These are principles, laws, theorems that govern how math processes and procedures are done. So these are the concepts or the theorems or the principles or the laws. First thing that comes to my mind are the exponent laws. Okay, because I teach more algebra than arithmetic. That's what I mean by concept. All right, these are the principles, laws, theorems, etc., that govern how math procedures are done. Second thing, these are the why behind the how. This is the why behind the how. I can show you how to borrow, but I need to also present why. So concept. These are the principles, laws, concepts, theorems, whatever you like to call them, that govern how math procedures are done. They are the why behind the how. The next thing, the third thing about concepts unify math problems. They unify math problems and procedures. It puts the problems together. This is important for you to see concepts and know concepts so that you can draw parallels and so forth. I do this a lot at the upper level in the algebra class, and I will make the comment, you already know how to do this. You already know this concept, okay? Let me illustrate that. I'll put it over here. Does anybody know what I call the law of addition? What's the law that governs addition? It doesn't really have a formal name, or maybe it does, I just don't know it. Nobody knows the law of addition? Okay, let me illustrate it and see if you can come up with it. I'll start with probably one of the first things. Can you do this? Let's say, can you add 2 yards plus 13 feet and get, how about we try this? "12 yards plus 13 feet equals 15 yeets." Or what else could we call it? I don't know. So, no. You cannot add units that are not alike. Now you can convert this, right? And you can do it, but you can't add it in this form. Let's try this. Can you add those? Why not? They have to have a common denominator. This violates the law. This violates the law. Let's go a little higher. Can you add like this? Let's say or more common, let me do it this way. Let's do 1.75. What's going to happen when you try to add that? Why? This is a concept. Why can you not do this? Why can you not add in this form? Why do you not set up your decimal addition this way? It violates the law of addition. Does anybody know what the law is now? You can only add, or do you need one more? How about one more example? Here's more my style. Can you add those? Why not? They're not like terms. We have to add like units, common denominators. These we have to add like places. We always decimal justify. I can't add the tenths to the ones, to the ones, to the tenths. Or the hundredths to the tenths, to the tenths, to the hundredths. Can I? What's the law of addition? You can only add like quantities. So this is a classic example of a math concept. It's a law that governs how procedures are done. It's the why you have to have a common denominator. It's the why you have to line up your decimals. Do you understand what I mean by concept? Okay, so in the teaching progression, we have terminology, facts, concept, procedure, expansion, problem areas, and application. And I call this a progression because this is how I work my way through a new section or a new concept or a new thing in a math class. Okay, we'll see you tomorrow.